So we need to consider and reflect just how lava moves downhill. Well, it does move downhill, so in some ways, thinking back to how rivers work and how water moves can be helpful here. But it doesn't move exactly like a river. So we really need to try and understand some of the mechanics of how lava like this moves. So what are you noticing in this GIF? This is within the first couple of days of the eruption in Geldingadalur Valley. Here you can see in the background the three splatter cones that developed initially along the fissure. What are you noticing about the way in which that moves? What catches your eye? Well, I'm going to take you through a little bit of a presentation where we look at some of the mechanics of how lava flows, and then we'll come back to this image and see if we can gather together our thoughts on our learnings on this. And the first thing that we need to consider is the topography of the land, because lava will, under gravity, move downhill. And there's a concept that really helps us to consider that, and it's a concept called the thalweg, which is the line of lowest elevation in the valley. So if you think of the watershed, which is the line of highest elevation, such that if the water falls to one side, it'll go into one drainage basin, to the other side, it'll go into the other one. So that's the highest point. The thalweg is kind of like the opposite of that. It's the line of the lowest elevation. So if the water then flows down a hill, it's going to go and find that thalweg and it's going to flow along there. So where in this little valley is the thalweg? If the rain falls here, where is it going to go? I'm sure you were ahead of me. The river is going to go down there. That's where the thalweg is. And it gets down to the bottom. What happens next? Because clearly we've got a little ridge here. We've got a rise in elevation. So what's going to happen next? Well, you might get the water forming a pond or a lake, depending on the topography there. So that is how water will probably flow down this landscape. What about lava? Well, in the first instance, yes, it is under gravity going to flow downhill. So you'll get your lava flow coming down here following the topography from higher to lower, and it will build up the land. But this is where lava is very different from water, because the lava on the way down, parts of it will harden. It will start to build up the landscape, and it will start to overwrite the existing topography. Hollows like this can be filled up. And if hollows like this are filled up, a subsequent lava flow, what's it going to look like? What do you think? It's going to flow over the top of the previous lava flow, which has overwritten the underlying topography, and all of a sudden, this lava can flow in a way that water doesn't. Lava can flow against the topography at times. Another thing to add in, which you probably saw in the GIF, the way in which the lava flows. The lava tends to form these rivulets along the surface of it, and the rivulets are surrounded by lava levees, these raised embankments, which are formed by the cooling or the partial cooling of the lava at the edge of the flow, and it then starts to direct these rivulets coming down towards the top, and this provides a very easy route for the lava feeding from the volcano up here down over the top of this. So again, if the water comes down the thalweg and reaches this lip and forms a pool here, it's maybe going to try and find a way down here if it's lower, or maybe begin to try and erode there, or find a way here depending. But the lava, when it comes down, can overwrite the underlying topography, can build up above it, and then the rivulets of lava that flow down over the top bring from the eruption source, whether a fissure or a vent, down towards the front and leading edge of the lava. Now, of course, it's semi-solid here, because underneath there can still be movement. It hasn't solidified. It solidifies from the outside in, the part of the lava that's in contact with the air will cool quickest. The bit that's deepest down will cool most slowly. So there will still be movement here. This isn't completely solid. So that brings us to the final factor here. that this hasn't completely solidified, and there is new lava which is solid rock. It's more dense than cement. It's very, very heavy solid rock, which, well, it's semi-solid rock, which is creating its own internal pressure, pushing forward, pushing further down. In this sense, then, the lava flow is a little bit more like a glacier. This is a solid block of ice that will flow. It will internally deform and push from the upland areas down towards the lowland areas. So you get that force pushing down as well because of the internal mass of the lava flow, which can also create that forward momentum, which can lift it up and over that kind of thing. So there we are. There is the lava flow. To what extent is it like a river? Well, the thalweg is helpful. It will flow downhill under gravity, but it flows downhill. It creates its own lava layer, which can overwrite the underlying topography, and subsequent lava flows, while building up, can therefore overcome topographical barriers. It can be fed by these lava rivulets, which bring a fresh supply of lava down towards the front of the flow, and the internal force of the weight and the mass of the rock pushing down creates that forward momentum as well. So let's take all of that together and come back to this. What are you seeing? Are you seeing any evidence of what we've just been looking at? Well, what if we start here? There's the forward edge is moving ahead. It is moving forward. It is relatively slow. And that's why you can see the people that are visiting here. But it is undoubtedly moving ahead. And you can see here that the flow is being fed, at least in part, by these rivulets bringing the fresh lava down towards the front. If you take a look at this one here in particular, down here, you can see how it flows over the top and then spills down the front. But you can also see how here the internal mass of the lava flow is moving forward as well. That has a surface that is cooled to a degree and hardened, but it's not completely solid yet, and the whole thing is moving forward slowly. As a result of that, as the subsequent lava flows ride over the top of the previous flows, the height increases, which allows you then to rewrite or overwrite the underlying topography. And all of that being fed by the vent, or vents in this case from above, which is constantly adding in new lava to the flow, creating these fascinating and interesting patterns. So how does lava flow? Well, it turns out lava flows in a really interesting and fascinating pattern, which means that our job of predicting where the lava flows might come next is an interesting and challenging one. So it's over to you now to see if you can predict where the lava's going to go.